speaker.
Hi. Hi, thank you. I'm happy to be here today. It's an awesome conference. Haven't been in the region at all, so I'm happy to meet you here. So today I'm going to talk about something that is really important in our developer perspective, but we don't pay that much attention to it, and that's performance. My name is Martin Kulov. I'm running a non-profit organization in software in Bulgaria called Association of Software Engineers. And I'm a Microsoft MVP for the last 12 years in the DevOps. Now it's called DevOps. It used to be Application Lifecycle Management. They now say it's not ALM, it's DevOps, basically in the Visual Studio tooling. So what we're going to talk today, okay, it's a DevOps world. We know it's a very abused word, but at the end of the day, what do we mean by DevOps? It's about the planning, about continuous delivery, about dev and test, and analytics. Basically, having the full life cycle from the planning, from the implementation of our work, to the delivery on the production systems, and taking feedback by gathering data from the production system. And by continuous delivery, we understand different things. First is the architecture, which by DevOps means, it actually means that we should not plan for big architecture up front, but we incrementally build the architecture, the so-called emerging architecture. Then is the agile software development, ways of doing software, which are Scrum, TDD, and whatever engineering practice you take. And then we have continuous testing, continuous deployment, and continuous monitoring. And today we're going to talk about continuous testing. Why? Because this is actually the first step when you want to do any kind of DevOps. And it is forecasted by Forrester and Gartner that any organization who wants to do DevOps today, they first start with testing. They have to automate the testing processes, and they have to do this kind of a shift-left movement, which is the testers and developers should not be isolated silos. They should work together, and that doesn't mean that our testers should write code from tomorrow, but instead this means that this shouldn't be an isolated process. Testing shouldn't be an isolated process. We should merge this as we go. And I'll show you how we can do that. It's in terms of performance, of course. And it's everyone's responsibility. The whole team is involved in delivering a quality software. By quality, we don't mean also bug-free, but also mean a performing software. And there it comes. Performance testing is part of the testing process. We should not leave it. And it is our responsibility as developers to make sure that our application is behaving fast enough, and we should not wait for someone else to fix our performance problems at the end of the sprint or in the end of the delivery of the application. If we do that, we will fail inevitably. So performance testing is something that we should do continuously as part of the continuous process. And I'm going to talk about what kind of instruments you should use to do that job. So performance testing is, as I said, everyone is responsible, and that also means that you are responsible. And I was told that it's a little bit politically incorrect here to talk about the American's president, but still we have this option here. So you are responsible to do the performance testing of your application. So there are actually, let's say we have 3 different steps in performance testing. First is the 3 different types, let's say, or we can also consider as a different steps. First is debugging. Then it's debugging the performance. Then we have profiling the performance and then monitoring the performance. 3 different ways to do that. And for every single one, as we will see, there are different tools. The good news is that most of the tools are actually available for us to use today. They're available in Visual Studio Professional Edition. So you don't need any kind of a fancy enterprise edition that costs much more money, but within Visual Studio, you can get all the functionality. All right, so before we start, let's first go quickly through some common definitions. First, how we do performance testing in general. We need to identify, is this a CPU problem, memory, network, or disk problem? These are the 4 different areas. If you don't know where the problem is, it'll be very hard to fix it. So first, you need to kind of narrow down which area do you want to concentrate at. Then locate what is the problem code that is giving you the performance problem. Then provide a fix and validate it. And as a general guideline, it's much, much easier to start measuring from the beginning. If you start measure at the end of your application, when you have tons of code already implemented, it will be really hard to get any proper measurements and to do any good analysis in a reasonable time, of course. Then you need to have set up your debug symbols, and I'll show you how you can do that. Also, you need to use release build of your application, and be careful of the observer effect. I'm going to talk about all this right now. So what are the debug symbols? These are the so-called PDB files. It's a program database files that gets generated automatically on the build for you. They get generated for debug and release configurations, and they contain additional information about how to debug your assembly. If this is an unmanaged code, it will also contain the different kind of optimization that compiler did for you. Also, what are the names of the variables in your application, and sometimes it can also contain, when the PDB is so-called indexed, it can also contain where your source code is located. PDBs are usually published to something that is called symbol server. And Microsoft has a symbol server that is available at this URL. It's msdl.microsoft.com. If you try to browse this, you will not get any valuable information. This is configured in Visual Studio, and it says, when I debug any kind of a Windows DLL file, try to download the PDB files from that Microsoft symbol server, download the PDB files on my machine, and help me with my debugging experience. It will resolve kind of very strange addresses in the DLL to a valuable, meaningful, human-readable name of the function. Just recently, Microsoft improved their symbol server, so they moved it as Azure-based storage, and they say it is now backed by a more robust publishing pipeline. They're doing this so they can, to allow them to immediately publish any kind of PDBs that they have from the insiders builds from Windows to go immediately to the symbol server. Also, there is a sweet, kind of neat symbol server path environment variable that you can set up to configure the symbols for your machine. But let's see how you can do that. Just a quick demo. Why did that happen? Okay. I will come to the code in a second, but just let me show you how you can do that. If you don't do this step, you won't be able to see much of the information that we're going to see in the next demo. So you go to debugging, and in debugging, let me see if I can make it like this. Yeah, in debugging, you select symbols, and you select Microsoft Symbol Server here, and you put a cache folder. which I usually use C column / M Microsoft Symbol Server, MSS. Okay, that's it. You have to click on that, click OK, and the symbol server is configured. That was easy. Okay. So, what do we have next? Okay, just hold on a second. This computer is behaving strangely. Oh, okay. Oh, okay, cool. So next we have debug versus release configurations. Anyone knows what debug and release configurations are? Have you used them? Put a hand, okay? Okay, cool. So I won't spend that much on that. You can configure it from here eventually, and with the debug configuration, what happens is that debugger keeps your objects in memory for a much longer time. And we had like, I won't say how many years ago because I'll look much older, but in many years ago we wrote a .NET book in Bulgarian, and then one of the showcases was to show how the garbage collector is working. And then one of the guys came to me and says, okay, I'm doing gc.collect here, and my object is still in memory, and I cannot understand why. I just collected it, the garbage collector is not working, obviously. And in the moment we just went to his project and moved from debug to release configuration, and the object disappeared immediately. So if you're deploying or working with any kind of debug configuration, that is a mess. You should use this only for debug purposes. Everything else should be unreleased. So all the demos that I'm going to show next are going to use, almost all of them, are going to use release configuration for that specific reason. So also keep in mind the observer effect. It's called also that you can introduce a hasten bug, that is a bug that only appears while you observe the software, or disappears while you observe it. A common scenario is that when you have some kind of a deadlock in SQL Server or any kind of a high traffic application, and you want to diagnose why this deadlock is happening and what is the performance problem, and in the moment you attach the debugger or run the profiler, and the problem disappears. And that happens because when you attach the profiler, you actually slow down the application. So the bug is no longer there when the application is a little bit slowed down. So keep in mind that when you attach and when you debug your application, you're changing the way it works. So the observer effect is there. So that applies to debugger, VS host process, VS test process, and profiler, or any other, of course. For a good reason, obviously, in Visual Studio 2017, they removed the VS host process, which I always disabled in my projects anyway, but they now removed it absolutely from the options. All right, so first step, debugging performance. Before you try to do anything else in performance optimizations, there are pretty nice tools that you can help you with your performance optimizations experience. First, this is SolarLint. Then we have code analysis, perf tips, and diagnostic tools. So let's talk a little bit about each of them. SolarLint is a Visual Studio extension that you can install from the extension and updates, from tools, extension, and updates. And it's a static code analysis. It analyzes your code as you type. It's a free extension. It's not from Microsoft, but it's a company called SonarSource. And it has different rules for vulnerability, code smells, performance, and many, many others. I'll show you how you can, what is the benefit of using it. Code analysis is something that is built in Visual Studio, and you can run code analysis on every single build run that you specify. Also, there are a lot of rules created for Microsoft, that, including performance rules, that can help you troubleshoot any performance reasons before they actually happen in your code. And it's a good practice to run it on every single build, so it's part of your continuous integration experience. And then we have perf tips. Perf tips is something that was introduced recently, and it shows you the time elapsed, as you can see down there on the right, the time elapsed on every single step that you go in Visual Studio, or you can just also use it as run to cursor with Control F10, and it will show you the total amount of time for execution until that breakpoint happened. And it's a good practice with Perf tips to take multiple measurements, because it's a debugger after all. Something can happen on your machine. So take multiple measurements and see how much it takes actually. It's kind of a pretty cool way to debug the performance and try to see if it's actually increased from the previous time that you have did any changes. In Diagnostic Tools, this is where we're going to spend most of the time. Diagnostic Tools, again, it's a new feature that Microsoft introduced in Visual Studio, pretty kind of a new. And it's using event tracing for Windows. These are special events that Windows DLLs kind of throw and trace all the time. And the cool thing about ETW is that they provide call stack. So when you catch one event like that, you can specify, you can tell ETW, okay, give me what is the call stack of this event. So where that event happened and what were the callees of that event. And it's a very high performing. That's why Microsoft moved to ETW compared to the standard profiler tools that we're going to cover them a little bit later. The tricky thing that you have to remember with Diagnostic Tools and event tracing for Windows is that it samples the time from the entry point to the exit point of the function. So whatever happens in between, it cannot tell you. It can tell you what is happening, what is the total time of that function from the start to the end, but it cannot profile inside of the function. Okay, let's see how this one works. Okay, so first I'm going to build a project. I have a sample project here. I built especially for the purpose. And here I'll go to the error list. And here you can see, I hope you can see it now. Okay. Here you can see like different rules and information messages. This is like S1144. S means that it's coming. This event is coming from SonarLint, the extension that I told you about, and it means it says remove the unused private method, blah blah blah, and that is some kind of a performance problem. It says code smell, but it's actually a performance because unused methods can bloat your code and make your assembly bigger. Okay, we also have remove use of gc.collect, which is, obviously there's a gc.collect in the code, which is not a recommended practice because you shouldn't do gc.collect on a general, you shouldn't use it on a general basis, just only in very rare occasions. So these kind of rules that you can just open the error list and see what SonarLint is giving to you, so you can easily fix it even before something as a problem has happened. One thing that you can also do is to use the code analysis. So in here, I go in Analyze and I say Run Code Analysis. And it will give me a little more information and warnings about my performance. So if I go to error list again, I can see, oops, sorry. I can see a few additional performance errors, performance warnings, that some methods should be static, and yeah, that this method should not be public because it's not being called by anyone else and stuff like that. So you can use these messages. You can see they're coming either from Sonar code or from the code analysis in the category performance. You can use to easily fix anything that happens without you knowing it. Okay, let's leave this for now. So let me show you the example project that I have here. I'm not sure if you can read that well, but what I have is a simple application. And I have been told, and that's a known fact from other speakers, that every single presentation should have a cat. So that's why I put a cat here. So this cat, there I have two buttons. One is load, and the other one is process. Process makes it a Halloween cat. But then I have a third button that it's load and process that does both things combined. So if I do load and process, you will actually not see any difference because load and process will load it again and process it just in one method call. Okay, so what we can do here, I have this load and process method that takes the URL, that takes the file name, reads the file into a stream, puts it into a bitmap, and then do some processing on the bitmap, kind of transforms the data, and then it shows it to this screen. And here we call gc.collect. We saw that this is not really good stuff to do that. Here you can see somewhere lint, it's underlying this usage of gc.collect. So we can immediately see any performance issue is in our code. Okay, so let me now make sure that I'm in debug. Let me now just run the application again with F5. And I'll load the picture. And then let me go here, go back in Visual Studio and open Diagnostic Tools. So this screen usually stays here on the right panel of your Visual Studio, but what I prefer to do is just go to the panel, right-click on the panel and say Doc as a tabbed document, which transforms the diagnostics window into a much more readable view. And in here I can see that I have a summary of what is happening in my application, and that summary contains how long I have been running the application, any events that have happened, like I just clicked the load button. We can see here the memory consumption, and this yellow thing marker here, it's a garbage collection. I cannot position it right now over there, but it's a garbage collection that has happened. Okay, generation to garbage collection. And if I go here and just say a few more times, load, no, not exactly, not load, but process. And on every single process, you see there is increase in my memory consumption. You see? So at some point, let me click a little more. At some point, the memory drops down. And this is where a garbage collection has occurred. So with the debugging, with the diagnostic tools, you can see how often you have garbage collection occurring. So what I can do now, go to the memory usage and just click take a snapshot. Now that my application has count down, let's do take a snapshot. And then I'll go back to my application, I'll put a breakpoint at the end of the method call, and I'll click again, process. What happened? Load process, did I click that? Ooh, okay. Let's redo that again. I clicked the wrong button. Okay, so my intention was to click load and process button. So I click here. Again, looking at the diagnostic tools, and let's click this a little more times, and you can see some garbage collection is happening. And now I'm taking a snapshot of the current usage of my memory. And then I click the button one more time, just this time, as previously, I want to put a breakpoint at the end, and I'll explain why. I put a breakpoint, and I click again, load and process. The execution goes on, and it stops at the end of the method. And here I can see there has been a little bit increase in the memory, and now I'm breaked into the debugger. So I can take a snapshot again, and look what is happening here. We have two snapshots and memory snapshots, and for each memory snapshot we have the heap size and what is the difference from the heap size from the previous snapshot, right? And if I'm not sure if you see that, if I click on that, I'll be smart just to click on the increase, right? And it will show me that the difference between the two heaps is actually a memory stream that is this size long. And what is cool that I can just click on it and I can actually debug what is the value of that object that is different from the previous snapshot. And that only happens, you can see the value, and let me actually go to the value just by going to the buffer. Okay, what happened? Okay, here it is. I can even run debugging visualizers on that object. That is the difference from the two memory snapshots. And I can see this is actually my image that got collected when I clicked the second time the button. That variable data, you can see the value of that variables only when you have braked into the debugger and then click a snapshot. Then you have clicked the take snapshot button, right? That's why I braked into the debugger and then I took the snapshot. Okay, so going through this, I told you, then I can continue just doing, oops, sorry. Hit the breakpoint again. Let me remove that breakpoint and just click the button multiple times. And in the Diagnostic Tools, you'll see that in the events, I have clicked a lot of times the button, and a lot of times there have been garbage collection. Okay, I really want to troubleshoot if there is any performance problem with my method now. However, I will be smart. I won't click 1,000 times here. So I'll just make it a little more programming experience. And I'll remove this GC collect because it's really not cool. All right, so process click. And in here I'll do for int. You know what? I will not do for int for, okay, let's do it all. For int e equals 0, 200, e plus plus. I will repeat this 200 times just to see how the application behaves. And now I'm kind of doing performance test in my developer machine. And what we just discussed about debug release mode, we should, when we do some kind of any performance test, let's change to release mode, release configuration. Because when we kind of load the application a little bit more, we want to measure what is the performance of release configuration. Okay, so I'll run this again. F5. Load and process. And in here, in the diagnostic tool, you'll see there has been some cycles over. Garbage collection is inducing and it's cleaning some memory. Okay, that's cool. I'm okay with that. Let's now enable. I clicked here on CPU usage. I may have rerun that again. I clicked on CPU usage and I clicked enable CPU profiling. And then, yeah, it finished. Okay, let me rerun that again. Okay, again, click on the button and go to the CPU usage tab of Debugging Tools, the Diagnostic Tools. In just a second, we are going to see the markers about garbage collection. Okay, here they are. Okay, now let's break all. So what we have here, we actually break into our piece of code. When I go back to Diagnostic Tools, it will show me what is the method that is mostly taking time in for my CPU. And in here, I can see that I have that the method load process click has taken like 84% of my time. And if I double click on that, you get this diagram that shows that, okay, load process click takes 84%, but it also calls the drawing bitmap and get h bitmap and functions like that. Okay, but remember what I told you earlier? We can see that this one is taking 84%, but we cannot see exactly what kind of a line in that method is taking 84%. So we cannot see what is taking so long. We can see on next level here, like 4216, but we cannot really see on a code level, on a line level, which line takes how much. That's because the process here is based on the ETW, and ETW can only measure from the beginning to the end of the function. Right, so I think I'm running very short on time. So what we can do more, in order to change that, I will use the same profiling process on the other button, which is only doing the work, which is doing the same work, but this time has isolated the image processing work into a method called apply filter. So let's do that again. And for int e, all right, so now let's run this again. Click on process, go to Diagnostic Tools, and here it gets garbage collected. And let's break and show Diagnostic Tools. And here we have the data. So we can see right now that button process click is called 80%, again, big number, but we have now split the work into two different function calls. One is the create bitmap source, which is taking 51%, and the apply filter, which is doing the actual image processing, into 38%. So just by splitting it in two different methods, shorter methods, I can tell what is taking most of the time. So as I did some kind of image processing before, I know that there is a much neat optimization, and I just browsed Stack Overflow, and I found that this create bitmap source that I'm using is not very much effective. This is actually showing the bitmap in a WPF application. So I have found a better implementation, which is convert to bitmap source, which I'll use in our show bitmap method. I'll just replace it here. And remember, this one used to be, create bitmap source used to be 51%. So let's rerun that again. Click on process. Go to Diagnostic Tools. What happened? Oh, it finished? Okay, let's do that again. Oh, that's actually pretty fast, if you can see. I couldn't even break it. Okay, so show Diagnostic Tools. And now you can see that process click, now apply filters takes 73% of my execution time, but convert to bitmap source has dropped to 13%. So this is a neat way just to see if you do any implementation, code implementation or performance optimization, you can easily see how much it takes in your code. We still have the problem that apply filter doesn't show where the overall time is spent. We just see it as a black box, right? Okay, I'll go a little bit with the slides. I don't have much time, unfortunately. Okay, so next step is profiling performance. Why do we need to profile it? Well, this is what we did is from the debugger. We seen that how to kind of create artificial load of our code and profile it with diagnostic tools. What if our application is already into a test environment and we want to hit it with a lot of load and see what is happening on a real machine, not on our development machine, right? So we use performance profiling. There is a Visual Studio Profiler and also a standalone profiler that you can install on the test machine and use a command line tools to do the actual profiling of your .NET implementation project. We also have COR profiler, and profilers are usually used when you have your application under load, so you can actually see what is happening inside. So there are different types of sampling of profilers. One is sampling and the other is instrumentation. Excuse me. The sampling profiler is non-obtrusive. It's again taking snapshots of your application on every kind of few hundreds or few thousand hundreds CPU cycles, and it takes call stack information from your application. It is different from ETW by the way it works, but it's kind of using the same idea. However, if it breaks in your code, it knows exactly what line of the code is actually taking how much time. The instrumenting profiler, on the other side, instruments everything, all your application, all your code, so it knows exactly how much every single line has been performing, but it only can see your code. Compared to the sampling profiler can go and end up into the Windows libraries. So it can sample data from Windows libraries, for example, but the instrumenting profiler can, because it's instrumenting your app, can only see your app and nothing else. So I'm going to show you how the sampling profiler works. I'm not sure, I don't think we can do it for the instrumenting profiler. So what I did here, analyze performance profiler, and it opens this one. And in here I select performance wizard, and I click start, and then I have, again, select the sampling profiler, CPU sampling. And I select that I want the WPF app, and just click OK. So my application runs, it needs to elevate some permissions. And I click here on process. So we wait for the image to show. It will take like 4 seconds, okay. So I close it, and now all the data that is collected from the profiler is aggregated and processed. And when this finishes, we can see, and again, this is something that you can collect this data using command line tools, using the standalone profiler on a production or test environment. Production is dangerous, but on test environment, it's okay. You can collect when the application is doing real load. There's a command line tools to do that. I just show you the Visual Studio experience, but there are also command line tools. Okay, so what is happening? Oh, and the process that is happening now is loading symbols from that Microsoft symbol server, right? So we can see what is happening. So here, we have again, a hot path that shows that we first go to app main, then button process click, and then we spend most of our time in apply filter. However, if I press here, we can actually see on every single line how much it takes to execute every single line of our code. This is based on sampling, so it's not a complete picture. I mean, if you don't run it long enough, you won't be able to get that much information, so it has to be enough data in order to be able to sample every single piece of your code. However, it's pretty good because it not only goes through from your code, but also goes to Windows code. And I can show you how this is possible. When I click here, show all code, and it will need some time to process the information again. Show all code, what happened? Okay, so now if I click on apply filter, just a second. Code tree, hot path. Oh yeah. Yeah, in here you can see that the sampling profiler has reached to other DLLs in our application and has created a full call stack of what is happening. Okay, enough of that. And the final thing I want to show you is the monitoring of performance. This is the last step. So we have debugged the performance on Visual Studio. Then we have profiled the performance on our test machine, and now we are running in production. So how we collect performance. And we have different tools to do that. That is performance counters, application insights, or any kind of enterprise instruments like Dynatrace, for example. Performance counters are available since Windows 2000, and they're basically, again, they're working as a sampling data, but different applications can report data. The problem with performance counters is the granularity of performance counters is just 1 second. So you can take samples from each application for 1 second, which is not very applicable for our high-performing world. But we have, there's a nice tool which is called PAL, Performance Analysis Logging Tool, which can analyze the performance counters, and as you can see on the below, gives you recommendation what is good and what is bad in your system, so you can improve it. However, not very useful these days. It's useful for basic so-called vital signs of your application. Then we have application insights. Really cool feature. Problem is that it is hosted in Azure, so you need to have Azure connection to send the data to. But it can instrument web apps, it can instrument desktop apps, anything beyond .NET 4.0, I think. And it also, a new feature that they just added is application map, so it gives you dependency map of what do you call through the different tiers. Or you can use Dynatrace, which is kind of the enterprise edition, enterprise product, which gives you a really much more complicated and sophisticated troubleshooting way, but it's also really expensive tool. It's not a Microsoft one. So how do we monitoring performance? And I think since we're going out of time, I'll just show you what I did. I took the same, method, which is my apply filter, and I put it into a web application. Here it is. And I published that web application into Azure. Controllers, help. Okay, you can see here, not help, no. And not help page. Okay, home controller. In process method, I just call apply filter 300 times. And I added application insights to that project, and I deployed the project to Azure. That's it. That's all I did. And let us see the result here. We have the application that is deployed in app service, and I can just go and in the app service, I can click on App Insights, and I can see the data from App Insights here. Then let me open the better view of App Insights. So what I also did, I've run some kind of availability monitors to incrementally and constantly hit my deployed application insights, my deployed app service, which is doing this apply filter job. And if I go here on performance, I can see that, okay, I need to refresh because the resolution make the experience bad. Okay, no luck with that. Okay, home process. And we can see just by using App Insights that we can get data, how long the App Insights, how long the call takes, how many calls do we have, what is the time that some problem happens, but also we can see here the really cool thing that they've added recently is Azure Profiler. When you enable the Azure Profiler, you can get profiler traces. So it's the same way that you do it in Visual Studio, but now in Azure, using the ETW tracing allows you to get that same hot path data while your application is running on production. And I did that without any changes in my code, without doing any kind of instrumentation on my side. I just click in Azure, enable profiler, here and there, and it runs fine. So that's it, and I think time runs out without for any questions, but maybe just one question and one summary that I want to say. This is a continuous effort. You should do performance profiling, performance testing all the time, and it starts from the beginning, and it doesn't stop until you complete with the project. And you just need to continuously improve because it doesn't happen from a day effort. And with that, I would like to thank you and to say that you can get 1 hour for free for performance troubleshooting session if you answer on that survey that I have over there. Just simple 3 questions about your debugging and performance experience. Why I'm doing this? Because I would like to understand from a real hands experience what are your problems, and so I can get better with that. And that will be helpful for you, so I can help you with your project. Thanks so much. And I hope I can talk later.
Yes, thank you for the presentation. Do we have some questions? Please raise your hand. No questions? Really? But it was interesting.
Well,
all right then.
I'll be outside.